Okay, so in this lecture, I want to talk about the gambler's fallacy. This is what Weisberg talked about in the chapter of his book I had you read. And I think Weisberg's explanation is pretty good, but I think it is useful to go through this stuff. And I want to say a little bit about conditional probability, too. He waits till the next chapter to talk about this. Um, you know, I don't know how deeply we're going to get into this. I do want to post a few more lectures on stuff next week on inductive logic, just to cover a little more. It's not going to be on the test. The test will only cover stuff we talked about this week. But I do want to say a little bit about it, so I'm going to introduce the idea today, at least formally, very basics. Okay, so let's start talking about the gambler's fallacy in some pretty obvious cases, right? So Weisberg uses the case of, somebody who's had, several girls in a row and they wonder, well, is it any more likely we'll have a boy next time, right? Well, let's take a more obvious case or some obvious cases of the gambler's fallacy. And of course, as the name would imply, the most obvious cases of the gambler's fallacy occur when people are gambling. If you ever go to Las Vegas or its cheaper, more depressing imitators, like, well, there are several in Mississippi or I forget where else, but Bethlehem, Pennsylvania, you know. Anyway, if you ever go to anywhere where there's gambling, be it Vegas or one of these other places, and you watch people, you will see them doing this a lot, right? So, imagine someone watches a roulette wheel and they see it come up red 8 times in a row. If you guys have never seen a roulette wheel, red, black, and then there's 2 zeros. Zeros mean everybody loses the money except the house. Red or black, you can bet on the color, you can make other bets, but if you bet on the color and your color comes up, you win, right? So it comes up red 8 times in a row. Does that mean it's a good bet to put money on black for the next spin or the next couple spins because black is somehow more likely, right? Or you watch somebody feed Lord knows how much money into a slot machine, do 30 rolls and they don't win anything. Should you go play that slot machine because, it's quote unquote due for a payout? In both cases, no, right? Look, if it's Vegas or if it's anywhere else with legal gambling, the odds that black is going to come up after 9 reds is not any more than if black came up last time or if there's only been 1 red and 1 black before, right? The odds are the same no matter what the last 9 or 10 spins have been, right? Slot machine, it's just as likely or unlikely to pay out on each spin, regardless of what's happened on the last ones, right? With both the roulette wheel and the slot machine, what happens on the next spin has no relation to what's happened on the last one, or the last 20, or the last 200, right? When people think otherwise, when they think, well, the slot machine's more likely to pay out because, it hasn't for a while, or when they think, well, black is more likely to come up because it hasn't for a while, that commits the gambler's fallacy. Look, people didn't commit the gambler's fallacy. Well, Vegas wouldn't make nearly as much money, right? I said, when I started talking about inductive logic, people are very bad at this. The fact that legalized gambling makes so much money really does depend on the fact people are bad at inductive logic. If you know this stuff, you probably won't be as interested in playing, right? Okay, so let's dig a little deeper into the gambler's fallacy. And let's talk about some of the technical terms related to it and how we define it and what's going on here. Well, there are 2 technical terms that we really need to understand the gambler's fallacy. There's some related terms, but the 2 terms we need are fair and independent. And so when we talk about something being fair, we mean no outcome more likely than another. Or if we're talking about two outcomes, one's not more likely than the other, right? Biased means that some outcome is more likely than another. So, great example of fair, coin flips are fair, right? If I flip a coin, have a nice silver one you guys can maybe hear, the sound effect. If I flip this coin, heads is just as likely as tails, right? It's fair, heads, tails, equally likely. In case you're curious, you can't see, it's actually tails. So unfair means one outcome is more likely than another. If you have one die, and you roll it, if it's fair, any of the numbers are equally likely, right? 1 is just as likely as 6. 2 is as likely as 1. Any of the 6 numbers are equally likely. Loaded dice, I don't know if you guys have heard of these. There's a bunch of videos online about how to make them. Most of the guys trying to make them don't do great. You can see they're obviously tampered with. But loaded dice, you hollow it out or you weight one side. There's other ways to tamper with dice. You can shave the corners and stuff. But loaded dice are dice that are tampered with. The whole point is they're not fair, right? Some numbers are going to be more likely to come up than others. If the person does it right, 5s and 6s are good, so those will come up more often. So, fair versus biased, right? The next term we really need to learn is independent or independence. Events are independent if one makes the other no more or less likely. They're independent if they have no effect on the probability of each other. Dependent, just the opposite of independent, means one event makes the other more or less likely. Example of independent events, coin flips, right? I got tails on the last one. That has no effect on how this one is going to come up if I flip it again, right? If I flip it now, which I'll just go on and do, I'll do it again. I don't think it really got the sound. It's a nice old silver dollar. Comes up heads, but the fact it came up tails last time didn't make that any more or less likely, right? The two events are completely independent of each other. One happening has absolutely no effect on the odds of the other. Example of dependent, the odds you get an A on your next French test, if you guys are taking French or a foreign language, dependent on whether you got an A on the last one, right? If you got an A on the last one, foreign languages are cumulative. If you ace the last test, that makes it more likely that you'll ace the next one, right? If you did badly on the last French test, it's not impossible that you'll get an A on the next one. You might really buckle down, but it makes it less likely, right? The two events are dependent on each other. If you guys ever watch baseball, another great example of dependent events, how well the pitcher does in the next at bat usually to some degree depends on how well he did on the last, right? Pitching, a lot of it is mental. Well, if he did well with the last pitcher, he's more likely to do well with the last batter. He's more likely to do well with the next one. If he really did terribly with the last one, well, it's less likely he's going to do well with this one, right? If you watch baseball and you see the pitcher walk a batter, he might strike the next guy out, but it's a bit less likely, right? All right. So hopefully the concepts make sense. Sorry to fall back on baseball. It's one sport I follow somewhat. The rules pretty well. All right. So let's go back to this term fair. Something is fair if the results are unbiased and independent. A roulette wheel is fair, at least between black and red. Red is no more or less likely than black. And assuming the game's not crooked, and if you're playing in Vegas or somewhere with legalized gambling, it's not, because it's just not worth it for them to cheat, they can take plenty of your money without cheating and not face any possible legal problems. Look, so the results are going to be independent. There are ways to tamper with roulette wheels. They're not going to do it in Vegas or other places with legalized gambling because they don't need to do it to take your money, right? So the gambler's fallacy is taking independent events to be dependent. Whether the roulette wheel comes up red on the 10th spin is completely independent of what's happened in the last 9, assuming it's not fixed, right? And it's not. Again, at least if it's in Vegas. The gambler thinks, or he takes, whether it comes up red or black on this 10th spin to in some way depend on what it's done in the last 9. That is a fallacy, right? The person at the slot machine, again, what it's going to do on this spin, if it's a fair slot machine, and again, if it's in Vegas, it's not worth them cheating you. They can take your money without it. Well, what happens on spin 100 does not depend on what's happened on the last 99. One informal way of explaining the gambler's fallacy and independence is to say that these things have no memory, right? The coin has no memory in the sense that how it's come up on the last 2 flips has no effect on how it will come up on this one, right? The slot machine, you could build one with a memory. That would be unfair. You would get in legal trouble. But a fair one doesn't have any memory, right? Each time you spin it, there's a little random number generator inside, and it generates a number. Some numbers win, most don't, right? What's happened on the last rolls have no effect on the future ones. The machine doesn't remember, it's not built to. So maybe, hopefully that makes a little more sense of it, what the gambler's fallacy is. So here's some other cases of the gambler's fallacy, right? Just to make the concept a bit more clear to you guys. One case that, is the one that Weisberg mentions at the beginning of the chapter I had you guys read. If somebody takes it to be more likely that they'll have a boy because they've had girls in the past, well, it's just not true, right? The gender of your next child in no way depends on the gender of the children you've had before, right? Turns out, we can do the science, that's just not the case. Or you think of somebody, imagine that I go into, the grocery store and I want to play the lottery and I'm lazy and I just look up whatever number won last week and somebody says, well, no, don't play that, right? Came up last week, what are the odds of it coming up again this week, right? Well, the whole process of picking the little balls is fair. They have the air thing or they pick it out. Somebody else with their hands. Most of them do the air thing these days, right? It is really unlikely that this number will come up, but it's no more or less likely than any other number, right? It would be astounding if the same number came up twice in a week, but just because it came up last week doesn't make it any more or less likely that this combination of numbers will come up next time. So, if you want to play the lottery, picking last week's numbers just as good as coming up with your own, right? There's another old joke about the gambler's fallacy. I can't remember who. I think some smart aleck philosopher or mathematician told this to a student of his who was scared of flying because she thought people were going to bomb the plane, right? And so this smart aleck, whose name I can't remember. I used to know this. I'll look it up for you guys. He joked to his student. He's like, well, bring your own bomb because, well, the odds that two people would bring a bomb on the plane are just astronomical, right? This, maybe it's a joke in poor taste. Definitely it's in poor taste if if somebody really has a phobia of flying and you're trying to reassure them, it's just kind of jerky, right? But it's a joke because it's an obvious case of the gambler's fallacy, right? Whether this poor scared student tries to sneak a bomb on, hopefully she didn't, just didn't take her jackass professor's advice, that is going to have no effect on whether somebody else tries to do it, somebody that she doesn't even know, right? The joke is funny, if it's funny at all, because it obviously commits the gambler's fallacy, right? Now, look, there might be some less clear cases. Your reading talks about the hot hands fallacy. Put it in scare quotes here. This is the idea that some basketball players get hot and are more likely to score when they get the ball. It's not clear whether this is a fallacy or not, right? Different analysis of what's happened say different things. So maybe how this guy's done on the last shot or two affects how he does on the next one. Personally, I'm inclined to think it probably does, right? So much of any sport's mental. What do I know? This is just my opinion, right? Another less clear case, my mom, I remember on more than one occasion, bought airline tickets right after a horrible crash, right? And is this the gambler's fallacy or not, right? If somebody just says, well, there's a crash last week, what are the odds we get another one next week? It's actually the safest time to fly. That would be the gambler's fallacy. But it's actually interesting what my mom would say about this, right? She would say, look, everybody is going to tighten up on maintenance. Everybody is going to tighten up on inspections. Everybody is going to be extra careful for the next couple months. So that makes a crash occurring less likely, right? So I actually think my mom didn't commit the gambler's fallacy. If somebody bought a ticket and said, well, their only reason for thinking, well, there won't be a crash next week is because there was one this week, well, that's the gambler's fallacy, right? Simple fact that it's unlikely the two would happen together, well, gambler's fallacy because, you're not telling me how a crash happening last week affected next week. I don't think my mom commits the gambler's fallacy or did because she gives reason to think that the two events aren't independent. In light of a crash last week, the airlines are going to do all this stuff for at least the next month or two that makes a crash less likely in the future. And that's a good sign. I'll talk about this in a minute. Do you commit the gambler's fallacy? Well, if all you can say is, well, it's really unlikely these two things happen together, you probably do. If you can tell some kind of story about why one event makes the other more or less likely, then you probably don't. All right. So why is the gambler's fallacy really tempting? Why do people fall for this? I think there are a few reasons. Maybe there are bigger philosophical reasons. People like to believe in justice in the universe or whatever. Won't get into that. But there are smaller reasons that people, I think, find this plausible. And the one is, it's really easy to confuse two related sets of facts. It is a fact that it is incredibly unlikely that you would get 10 tails in a row if you flipped a fair coin 10 times. I did the math. You basically, it's 1/2 each time. So you just, you square that. It's literally 1 in 1,024, right? The odds of getting tails on any one flip, though, are 1/2, right? If you offered me a bet, what are the chances that the next 10 flips all come up tails? I wouldn't take it because it's incredibly unlikely. Well, if you offered me a bet, what are the odds that the next coin comes up tails, even though there's been 9 in the past, I would still say, well, it's 1/2. I would probably take that bet with some kind of fair odds, right? And now look, before you start flipping those coins, the odds of getting 10 tails in a row, 1 in 1,024. If you've got, but if you now have 9 tails, the odds of getting, 10 tails in a row are now 1/2 because all you need is one more. And the odds of that happening are 1/2, right? So these are two related facts, and I think people confuse them. Before you start flipping the coins, it's incredibly unlikely you're going to get 10 tails in a row. Once you've got 10 tails, once you've got 9 tails, suddenly it's no longer so unlikely that you'll get the 10th, right? Hopefully that makes sense. It's a little complicated, but I do think people mix these two ideas up. Another reason the gambler's fallacy is so tempting, in real life, it's not always clear when events are independent or not, right? Look, we like roulette wheels, we like slot machines, because by law, these things have to be independent, right? If the casino makes what happens with the roulette wheel in any way dependent on what's happened in the last spin, they can have magnets or stuff or cheat, well, they can get in a lot of legal trouble. It's just not worth it for them, right? The slot machine, what happens on the next spin doesn't depend on the last because, again, we know it has to be independent or they would get in a lot of legal trouble. In real life, it might seem that events are independent, but it's often unclear, right? What are the odds that it rains today given that it rained Tuesday a year ago, right? I don't see how in the world those events could depend on each other. Then again, what do I know about the weather, right? Does anybody know about the weather, right? Maybe it's just not clear whether those events are dependent or independent, whether one really has a bearing on the odds of the other one, right? So in real life, it's often really unclear whether things are dependent or independent. Weisberg's example of the hot hands fallacy in basketball, another good one. We still don't know whether how well they do on the next few shots depends on how well they've done on the last few, right? Another reason, I think the final one, relates back to the second one. When seemingly unlikely things happen together, it's often decent evidence that even though they seem independent, they're not, right? If, I go back 20 years and I find that every time it rained on a Thursday a year ago, it rains on the Thursday this year, well, that would be pretty darn good evidence. Well, I don't know how good, but it would be good evidence that there's some kind of dependence going on here, right? If the roulette wheel comes up red 30 times in a row, that's probably pretty good evidence that it's not fair, right? That this is a crooked wheel, that in some way the events of the last spins, or the events of each coming spin depend on the last ones, right? If it comes up 30 reds, then probably they're tampering with it in some way, right? In the real world, we know that Vegas casinos aren't going to tamper with their wheels. It's just not worth it. But if you were in some shady underground, not legal casino, then you might start thinking, right? All right, so hopefully that gives you some idea of why the fallacy is so tempting. Now, as I said a few slides ago, a good guide here is, can you give reasons, beyond the fact that it's unlikely these two things occur together, to think that the one event makes the other one more or less likely, right? It's really unlikely that all kinds of events would occur together, I'm trying to think of an example here, but obviously things being unlikely to occur together, they have no bearing on each other. If you can give reasons to think that the one affects the other one, or that they're connected in some deeper way, then you're not committing the gambler's fallacy. If you can give reasons to think they're related. You might not be right, your theory about why these two things are connected might be crazy. My uncles love NASCAR. A lot of times their drivers wouldn't win for a while, so they decided NASCAR racing was fixed. Well, if whether Dale Earnhardt Jr. wins this week depends on whether Kyle Petty won last week. I don't know nothing about racing. I don't even know if those guys were racing at the same time, but whatever. But, if those really, if NASCAR racing really is fixed, then, they're certainly not committing the gambler's fallacy. I don't think NASCAR racing's fixed, so they're probably making a lot of other errors in logic and reasoning. They're not committing the gambler's fallacy, though, right? But if all you can say is, well, it's really unlikely these two things occur together, if that's the only story you can tell, you are almost certainly committing the gambler's fallacy. All right, last thing I want to say, just a quick introduction to conditional probability. I think the gambler's fallacy is a good way to introduce this, and I think that the idea of conditional probability, allows us to get a better idea, a more exact idea of what's going on with the gambler's fallacy. So, conditional probability means the likelihood of one event occurring if another does. Here's some examples of conditional probability. What are the odds of the pitcher striking out a batter given that he's walked the last 3? What are the odds that we have in-person classes in the fall given this week's number of coronavirus cases in Virginia? What are the odds, sorry to be so bleak and talk about, pandemic stuff, but of course it's on anybody's mind, right? Pandemic's horrible. It actually is a pretty good lesson in inductive logic and probability, sadly enough. What are the odds of a vaccine within the next year, given that several vaccines work in monkeys, right? I read this week they have 3 that actually work in monkeys. Let's see if they work in people, right? Each of these things, there's going to be an effect, right? It's less likely the batter is going to strike out this one if he's walked the 3 before. If cases have went down sharply this week, it makes it a bit more likely we're going to have classes in the fall. If they've went up, less likely. The fact that these vaccines work in monkeys make it more likely we'll have a vaccine in the next year, right? So conditional probability, what are the odds of A given that B? And that is the formal definition of conditional probability. And so we'll introduce one more little symbol here, right? Told you we don't use the arrow symbol in inductive logic. We do use this, if you look in the Weisberg, we use this little bar symbol. Conditional probability, probability of A given that B, PR, A, little slash or bar sign, B. Like conditionals in deductive logic, the order is very important here, right? With the other stuff with inductive logic, the order doesn't matter. Probability A or B, same as the probability B or A, right? Probability A and B, same as the probability B and A, right? With conditional probability, the order matters very much. The probability of A given that B might be very different than the probability of B given that A, right? Let me give you guys an example. The odds that you passed a class, given that you made an A in it, are very good, right? In fact, this is one of those cases where the odds are probably 1, right? 100%. The probability that you made an A in a class given that you passed it, well, not as good, right? You can't, barring some weird circumstances, you can't make an A in a class and not pass it. On the other hand, there are possibilities for passing a class that don't involve you getting an A, right? So order matters very much here, right? As with conditionals in deductive logic. Final thing, and like I said, I think I will, because I did want to talk about this. I think stuff's useful. It won't be on the test, but I will talk a bit about it if you guys are interested next week, just to get a little more deeply into it. Formal definition of independence is this. A is independent from B if the probability of A given that B is exactly equal to the probability of A. Think about this with my example of coin flips. The probability that the second coin flip, we'll call that A, comes up heads, given that the last one came up heads, we'll call that B, is exactly the same as it is if we know nothing about how the last coin flip came up, right? It's 1/2. The fact that the last one came up heads doesn't affect it. It's 1/2 if we don't know that. It's 1/2 if we do know that, right? So independence, probability of A given that B is exactly the same as the probability that A. B does not affect the probability of A in any way. Okay, so hopefully that's all clear to you guys. If you take nothing else from the inductive logic section of this class, it's the sad lesson. If you gamble in Vegas or anywhere else with legal gambling, you are not going to make money. In the long run, there's no sure strategy to do it. So don't ever gamble, at least in Vegas, thinking you will make money. My wife and I were there beginning of the year. We saw a lot of people losing a lot of money. In many cases, money they didn't seem to be able to lose, right? So, if you get no other lesson from inductive logic, don't do that.